Om Sri Sai Ram. We are beginning a new topic after doing calculus, and the topic is about vectors. We have come across this term vectors in physics, in mathematics earlier. In physics, we have studied it in little bit detail also. But in the same time, the elaborate study of vectors we are going to do in this particular chapter. What are vectors? When you look outside, you come across many things which can be measured. For example, our own weight, our own height, length of a particular object, distance traveled by a person. All these are physical objects, physical things which come into two categories. For example, height and weight. We call them scalars because when you are measuring height, whether you measure from top to bottom or bottom to top, it remains same. Similarly about weight. Similarly about distance. From the college to hostel, whatever is the distance, same is the distance from hostel to college. So the distance is also considered as scalar quantity because it involves only the magnitude. Where there is only magnitude involved and we have nothing to do with direction, such quantities are called scalar quantities. There are many things in that. But in the same time, there are certain quantities which involve magnitude along with that the direction. For example, suppose you have an object and you have pushed it. So it depends upon which direction you have pushed because accordingly it will reach a particular point. Since the direction is also involved, it is not only the distance but the direction also. We call it displacement. Displacement is a vector quantity because you need to mention the direction. Similarly, velocity. Speed is a scalar quantity but velocity is a vector quantity because you need to mention the direction. Acceleration is a vector quantity. So basically we have two things. One type of things we call them scalars, another we call them vectors. Those which involve only magnitude, we call them scalars. Magnitude and direction both, if they are there, we call them vectors. So let us move on and learn things connected to this. So vectors we have discussed. Physical quantities which have got magnitude and direction are called vectors. Position vector. What is position vector? On an xy plane, if you consider origin as the starting point and represent another point, let us say this is an xy plane, this is the origin, and from origin, suppose we have a point here. If we join these two in this particular direction, we say it is the position vector of P. What is the position vector of P? It is OP. So what is happening? We are not only measuring the distance OP, but we are also showing the direction. Every vector will have initial point and terminal point. Okay? If the initial points are from the origin, very easily we can find the position vectors of the point. Okay. Direction cosines. This is something very interesting. This we also study more elaborately in 3-dimension geometry also. So, what is it actually? For example, same diagram we can use it. Suppose this is x-axis, this is y-axis, and here we have a z-axis perpendicular to that. Since it cannot be drawn on a 2-dimension board, we draw it this way. Let us say this is z-axis. Remember, all the 3 axes are perpendicular to each other. Think of a corner of a room. One side we can call it x-axis, another side you can call it y-axis, and the vertical line we can call it z-axis. The length can be taken as x-axis, width can be taken as y-axis, and the height can be taken as z-axis. So, what are direction cosines? Take any vector, for example, OP is a vector, find out the angles which this particular vector makes in positive direction of x, y and z axis. Now, for example, this is the x axis we have set. So, this is the angle which is making. What do you mean by positive direction? The anti-clockwise direction is considered as positive direction. So, let us say this is the angle alpha. Similarly, the vector making angle with y-axis, let us say this we are calling it beta. Similarly, the angle which this particular vector is making with z-axis, let us say we are calling it gamma. The angles which a particular vector makes in positive direction with x, y and z axis. So, this is the angle alpha, this is the angle beta, and this is the angle gamma. These are the angles made by a vector with respect to coordinate axis. Cosines of these angles are called direction cosines. What are direction cosines? Cosines of the angles made by a vector with x, y and z axis in positive direction. We represent them as cos alpha, cos beta and cos gamma. In short, the first one we call it L, second one we call it M, third one we call it N. And there is a very interesting result between them. What is the result? The result is L square plus M square plus N square equal to 1. Why it is 1? We will come to know as we move further. L, M, N are called, in short, direction cosines. What are direction cosines? Cosines of the angles made by a particular vector with x, y and z axis. Types of vectors. There are so many types of vectors, beginning with zero vector. What do you mean by zero vector? Suppose this is the starting point of a vector, and suppose this is only the ending point also. The initial point and terminating point both are same. So, what happens? The magnitude is 0. So, if the magnitude is 0, we call it a zero vector. It still has direction, but its magnitude is 0. Unit vector. Unit vector whose magnitude is 1. Any vector whose magnitude is 1 is represented by unit vector. Generally, we use I, J, K as unit vectors, and this is the symbol which is used for unit vectors, a cap for unit vectors. So, I, J, K we call them unit vectors. Co-initial vectors. Two vectors whose initial points are same. Let us say here is a vector, here is another vector. Suppose this is OA, this is OB. Initial points are same, terminating points are different. We call them co-initial vectors. Then we have collinear vectors, vectors which are in one line or vectors which are parallel. Suppose here is a vector, here is another vector. Suppose both of them are parallel to the same line, So we say A and B are collinear. They are in one line, you can put them in one line, or they are parallel, because both of them are parallel to a given line. So they are called collinear vectors. Next is equal vectors. What do you mean by equal vectors? Suppose if you say we have a vector A, this is the symbol we use for a vector. Suppose there is another vector B and both of them are equal. What do you mean by saying two vectors are equal? If two vectors are equal, two things should be equal. One is their magnitude should be same and the direction should be same. How do you write the magnitude of a vector? By putting them in between the vertical lines. Modulus. Modulus of a vector means length of a vector. So if modulus of A is equal to modulus of B, this is the first condition, and the second condition is the direction is also same. So equal vectors. Negative of a vector. There is very small difference between equal and negative. In equal as well as negative, magnitudes are same. If directions are same, we call them equal. If directions are opposite, we call them negative vector. Okay. Based upon what we have discussed, we have a small exercise. Let us do this exercise. What he says, represent graphically a displacement of 40 kilometers 30 degree east of north. This is very important. 30 degrees east of north. So take any point, let us say here is the initial point O, and we have the general idea about the directions. What is the idea we have? Suppose we represent the directions this way, the upward is always north, this is east. If that is north, this becomes south, this becomes west. From the initial point, he says east 30 degrees east of north. Suppose if he says north, north means upward direction. This is north. He says east of north. East means right side. How much? 30 degrees. So this is the vector he is talking about. OP is a vector and this is the angle 30 degrees. OP is a vector which is 30 degrees east of north. Then he has given the magnitude. Magnitude he says is 40 kilometers. Since we are representing on the graph paper, let us assume that 1 centimeter represents 10 kilometers. Suppose 10 kilometers is equal to 1 centimeter. So 40 kilometers is going to be equal to 4 centimeters. So this length should be 40. Let us say this is the point. So this, let us say this is 10, this is 20, this is 30, this is 40. So the magnitude of the vector is 4 kilometers. The direction is 30 degrees east of north. Some very simple questions in order to understand the concept of scalars and vectors. Classify the following measures as scalars and vectors. Here we have some 6 of them. Read each of them and think whether that requires direction or not. If it requires direction, it is vector, else it is scalar. 10 kg. 10 kg whether you measure at home or in school or in market, it is same. It doesn't require direction, so it is a scalar. 2 meters northwest. 2 meters northwest. We are showing the direction. So here is a vector quantity. 40 degrees. 40 degrees you can measure it clockwise direction, anti-clockwise direction, whichever direction. So it is again scalar. 40 watt. 40 watt, let us say we have a bulb. So whether you put the bulb upside down or you put it straight, it is same. So this is also a scalar quantity. 10 to the power minus 19 coulomb. We measure electricity with the help of this, is a scalar quantity. 20 meters per second square. Meter per second square is the unit of acceleration. and we know that acceleration is a vector quantity. So this is also vector. Classify the following as scalars and vector. Once again the similar kind of thing. Time period. Time period doesn't require any direction, so it is scalar. Distance also does not require direction. Distance from hostel to college, college to hostel is same. So this also a scalar quantity. Force. Whenever you are applying force, you have to show the direction. So it is a vector quantity. Velocity. Speed is a scalar quantity, but when we say velocity, we have to mention the direction. So it is a vector quantity. Work done is a scalar quantity. So in this way, we have made a distinction. Let us come to the next set of questions. He says, identify the following vectors. Co-initial. What do you mean by co-initial? Vectors whose starting point is same. Initial point is same. So look at in this particular diagram, which vectors have the same starting point. For example, A and D. D is in this direction, A is in this direction. So co-initial vectors are A and D. He is talking about equal vectors. Which vectors are said to be equal? Whose magnitude is same, direction is also same. Look carefully. Here we can see that this is D and this is B. They are the sides of a rectangle, so the lengths are equal, direction is also same. So we can say that D and B are equal vectors. Then he says collinear but not equal. Collinear. What do you mean by collinear vectors? We have already discussed which vectors are said to be collinear. They are parallel to the same line. Okay, but not equal, he says. They are not equal means you can take them opposite direction. Okay, so which are such vectors? Observe carefully. The vector C is in this direction, vector A is in that direction. Both are equal in magnitude but opposite in direction, so we can take A and C. So these are the answers. Similarly, answer the following as true or false. Let us move further from those few definitions. We are studying about addition of vectors. Suppose you got two vectors, one is A, another is B. If you are able to represent them as two sides of a triangle, for example, AB is one vector, BC is another vector. So AB vector plus BC vector is equal to AC vector. This is called triangular law of addition. AB plus BC is equal to AC. But never be under the impression that length of AB plus length of BC is equal to length of AC. Wrong. Sum of the lengths of the sides will not be equal to third side. If it is so, you cannot draw a triangle actually. But the sum of two vectors is equal to third vector. If two vectors can be represented as two sides of a triangle in one particular order, then the third vector is going to be equal to sum of the first two. So AB plus BC is equal to vector AC. So that's what is been explained here. Let us move further. Yes, parallelogram law of vectors. What we saw was triangular law of addition. What was triangular law of addition? If AB and BC are representing two vectors consecutively, then the third side will represent sum of these two. That was called triangular law of addition. Now we are talking about parallelogram law of vector addition. What do we do in this? Here also we take two consecutive sides as two vectors. Let us say OA is one vector, OB is one vector. How do we add it? We know that in a parallelogram opposite sides are parallel. So whatever is the length of OB, it is going to be equal to AC. So whatever is vector AB, same will be AC. How much is OB? It is B. How much is AC? That is also going to be B. So by triangular law of addition, you can say that OA plus AC is equal to OC. In the same manner, if you take these two sides, this side is vector B, since this is A, being a parallelogram, that is also going to be B. So it B plus A is equal to A plus B. This we also repeat once again when we are going to study about commutativity of sum of two vectors. What do you mean by commutativity? Vector A plus B is equal to vector B plus A. So this is called addition of vectors by using the sides of parallelogram. So we call it parallelogram law of vectors addition. So what does it mean? Basically, if two of the sides are representing two vectors, then the diagonal will represent sum of those two. Parallelogram law of vector addition, same thing he continues. He says OA plus AC is equal to OC. Similarly, OA plus OB is nothing but A plus B is OC. The same thing he is explaining further. Yes, this is the property as I was mentioning. We once again repeat the property when we talk about commutativity of two vectors. What do you mean by commutativity? If A and B are two vectors, then A plus B is equal to B plus A. Suppose we have two vectors AB and AC as vector A and B. We know that this vector AB will be equal to DC. Why? Because in parallelogram opposite sides are equal, magnitude is same and you are keeping the direction same. Similarly, the vector AD is going to be equal to BC. Why? Once again the opposite sides are equal, we are keeping the direction same. So, if you add AB with BC, you will get A plus B. Whereas if you add AD with DC, you are going to get B plus A. Both are giving you same diagonal, same vector. So what do we conclude? We conclude that vector addition follows the commutativity. Yes, similarly associativity. You simply pick up three vectors. Let us say we have a vector A, we have a vector B and we have a vector C. We want to add. How do you add? You want to add A and B, join this diagonal. So how much is this is going to be? It is going to be A plus B by triangular law of vector addition. Now add this with this one, you will get this side. So how much is this? This is A plus B plus C is called A plus B plus C. First we added A and B. Whereas in the second situation, what you do is add B and C first. So if you add B and C, you will get vector B plus vector C, that is QS, that is B plus C. Now add A to that. So A plus B plus C, you are going to get same PS as we got here. So the conclusion is A plus B plus C is equal to A plus B plus C. What we are trying to say? That it follows the associativity. So triangular law of vector addition follows commutativity, also follows associativity. Very, very simple it is. In the first case, add A and B first, and in the second case, add B and C. Then add A there. Here you add C next. You get the same vectors. The same thing is explained here. Yes, multiplication of a vector by a scalar. Suppose you have a vector A. If I multiply with 5, what will happen? When I multiply a vector with 5, magnitude will get multiplied by 5, but direction will remain same. So if you multiply a vector A with any scalar quantity k, it will become k times. Direction will not change. Only magnitude will get multiplied k times, c times, a times, whatever you want, you can say that. Yes. Geometrical visualization, same thing we are trying to understand. Let us say here we have a vector A. Now if you multiply it with a half, what will happen? Its length will become half. So that's why it is half A. Suppose if you multiply this vector with 2, what will happen? The length will become double. length became double, so it became 2a. Suppose if you multiply with minus half, what will happen? The length will become half. Since there is minus sign, the direction also will change. Suppose if you multiply with minus 2, what will happen? Length will become double, but the direction will become opposite. So we can even understand by seeing these figures. Yes, this is very, very important. Components of a vector. Let us take a point A. Where does the point A lie? It lies on the x-axis at a distance of 1 unit. Similarly, OB, the coordinate is showing that its length is 1. Similarly, C, coordinate is showing that its length is 1. So we have unit vectors along x-axis, along y-axis and along z-axis. Since they are unit vectors, we represent them by I, J, K. I, J, K represent unit vectors along x-axis, y-axis and z-axis. I along x-axis, J along y-axis and K along z-axis. They are unit vectors because their length is 1 unit. It can be 1 millimeter, it can be 1 centimeter, it can be 1 inch, it can be 1 meter, whatever it is, but 1. Okay. So, modulus of OA is 1, modulus of OB is 1, modulus of OC is 1. Means what? The lengths are 1, 1, 1. Having magnitude 1 called unit vectors along OX, OY and OZ, and we represent them as IJK. So, when I am writing IJK, let us say I put a cap. What does it actually means? Magnitude is 1 and direction is along x-axis. Means what? The modulus of I is 1, which is also same for modulus of J and is also same for modulus of K. All of them have got equal magnitude 1, but I is along x-axis, J is along y-axis and K is along z-axis. So put together we write the position vector of a point. Okay. Yes, components of a vector. After learning IJK, this is a very, very important thing which we learn. This is called components of a vector. Suppose we have a vector, how to write it in IJK form? How to write it in component form? IJK, I is along x-axis, J is along y-axis and K is along z-axis. How to write it? So, let us consider one corner of a room as origin and opposite corner, the top corner, he is taking it as P. It has got coordinates x, y, z. Why it has got coordinates x, y, z? Because it is in the opposite top corner. How do you reach it? From the origin, first you go diagonally. When you go diagonally, you will be traveling x and y and you will be reaching the corner point on the floor. What will be its coordinates? X, y, 0. Then you go upward vertically, you will reach the point Z. So, the corner point coordinates are going to be x, y, z. Same thing we can understand other way. Now take the corner point and from there you draw a perpendicular. When you draw a perpendicular, it will fall on the floor but on the opposite corner. So, P1 is that perpendicular. Means from P you have drawn a perpendicular. So, what will be the coordinates of P? It are going to be x, y, 0. And how do you reach P1? It is OQ plus QP1. OQ is how much? Xi. QP1 is how much? Yj. Coordinates are x, y, 0. Okay. And then how much is this distance P1 to P? It is Z. So the vector is going to be So the coordinates are going to be x, y, z, and the vector OP can be written like this. What way you can write OP? OP we can write it as, first we will write OP as OP1 plus P1P. Check what is OP1. How do you reach OP1? Even though this angle looks like obtuse angle, it is not obtuse angle. Think of a corner of the room. The angle is 90 degrees. So from one corner to another corner, how do you reach? First we will go x distance and then we move y. So this is OQ and then QP1. So OP1 can be written as OQ plus QP1 plus P1P. So how much is OQ? OQ is xi. So OQ is xi plus QP1. How much is QP1? Remember, this is parallel to y-axis. Parallel to y-axis vector is yj. So QP1 will become yj. How much is P1P? Remember, P1P is parallel to z-axis and the vector is zk. So the vector OP can be written like this. And if you write the vector in this way, it is called component form of a vector. So what is the component form? ijk form. So what is it? If the coordinates are x, y, z, then it is xi plus yj plus zk. The same thing he is explaining. OP1, OP and then R. Length of a vector. If the vector is given in component form, how you can find the length of the vector? Same, OP. How do you find out OP? Modulus. Very simple. If R is a vector xi plus yj plus zk in component form, how do you find length of the vector? By taking the modulus. What do you mean by modulus? Under root of x square plus y square plus z square. Okay. It is more or less like by using distance formula, because initial point is origin, other point is xyz. So it is x minus 0 whole square, y minus 0 whole square, z minus k whole square under root. So that becomes the distance of the vector. If A and B are any two vectors, both are given in the component form, how do you add it? How do you add two vectors which are in component form? We add I component with I, j component with j, k component with k. That's why, suppose first one is a1i plus a2j plus a3k, second one is b1i plus b2j plus b3k. So how do you add? a1 plus b1i, a2 plus b2j, a3 plus b3k. This is how we write a vector. This is how we add. This is how we subtract also. If you have to subtract, put the minus sign. So what is that we are doing? We are adding or subtracting the components. I component with I, j component with j, k component with k. Properties. Two vectors A and B are equal. When they will be equal? When their components are equal. So A1 is equal to B1, A2 equal to B2, A3 equal to B3. Similarly, the multiplication of a vector A by a scalar. What happens if you multiply a vector with a scalar? We already discussed, magnitude gets multiplied lambda times. But if the vector is given in component form, what happens? Same thing happens. If you multiply a vector with lambda, the magnitudes will get multiplied with lambda. Okay. If A and B are any two vectors and K and M are any scalars, these are some of the properties of scalar multiplication. What are the properties? Ka plus Ma can be written as K plus M into A. Something like 2A plus 3A can be written as 2 plus 3A. Simple. K into Ma equal to Km into A. Remember, K and M both are scalars. K into A plus B can be opened up as Ka plus Kb. With this, we come to a close of this particular topic, the first part of vectors, and we thank all of you for patiently watching and learning. God bless. Thank you.